All right. So to graph a square root function, three things we're going to do. We're going to start by identifying the domain of the function. Then we're going to make a table of values to graph the function. And finally, we're going to identify the range of the function. So let me start with our first problem. Which is y equals the square root of x plus 2. The plus 2 is not under the radical. In fact, sometimes you might see this written in reverse order, and it might be written as 2 plus the square root of x. Really doesn't matter which way you write it. You've got to figure out where the radical is, because in the square root function, that's going to determine your domain. And so what we do is we take the radicand, what is under the radical, and we set that greater than or equal to 0. And if we have to solve, we do. In this case, we don't have to solve. And as a result, that means our domain of this function would be where x is greater than or equal to 0. So what I'm going to do is actually make a table of values where I start my table at that critical value of 0, and then every other value in my table for x needs to be a value greater than 0. Equal to 0 we already have. I want to be selective. I could test any number, but we're taking the square root. Wouldn't it make sense to test perfect squares? Because we wouldn't have to rely on a calculator for an approximation. But theoretically, any number greater than 0 works. It's just you don't want to have to depend on a calculator. So what values would be good values to test? And I would test 2 more. Tristan?
149.
What was that?
149.
Okay, 1, 4, and 9. And actually, I only need probably 3 of them, but I could test all of these. So let's go ahead and put those. They're all perfect squares. So now think about what happens. If we put 0 in here, the square root of 0 is 0 plus 2 is what? 2. Now put in 1. What's the square root of 1? 1 plus 2 is 3. It's always the positive or principal root unless there's a minus in front of that radical. So you don't have to worry about plus or minus. If we put in 4, what's the square root of 4? 2 plus 2 is 4. And if we put in 9, square root of 9 is, plus 2 is. Now I can graph it, which I'm going to do here in a moment on the grid, but I can also figure out my range from here as well. This first point is going to tell me both domain and range values. I already stated that the domain has to be x greater than or equal to 0. Thank you. I can't take the square root of a negative. Is that getting it?
No, it won't stay up.
Thank you. So I can't take, does that work?
Yeah.
There we go. Thank you. I can't take the square root of something smaller. That's why it had to be greater than or equal to. For the range, though, do you notice that the y values are also getting larger? This starts at 2, but my y's are all bigger. And if it's bigger, it should be reflecting the top half of that horizontally opening parabola. So I'm stating that the domain is x greater than or equal to 0, and the range has to be 2 greater than or equal to 2. Let's see what the actual graph looks like. So if I graph over here, Yeah,
I'm confused on like the domain kind of that you put, like, is it always gonna equal x is greater than or equal to 0?
no. We'll see in our next problem, it's not necessarily always 0. Sometimes it is, but not always. It depends on the radicand. The radicand, what's under the square root symbol, is what determines the domain, and that is not always going to be x. But the reason you set it greater than or equal to 0 is because you can't take the square root of a negative.
Right.
You can take the square root of 0 or any positive number. So the radicand has to always be set greater than or equal to 0. But then we always solve it for x. Graphing here. I would just graph my points. 0, 2, that's right here. 1, 3, right here. 4, 4, right here. And 9, 5, I know this goes 10 units. So 9, 5 would be here. Does it make sense that that's what our graph looks like? It's not a straight line, it's a parabola. Half of a parabola opening horizontally. And by the way, transformations, do you see how the +2 is shifting it up 2 units above the origin? That's what that +2 is doing. It's shifting the graph vertically 2 units up. Because the base graph has its starting point at the origin. And that's it. That's how you graph a square root function. So it's not as hard as you might think. Let's, go ahead.
So to get like the other, is there like a bottom half to that?
Nope, because if we had the inverse, we would have the bottom half.
Right, can we find
And that's
this?
plus or minus, but we don't want that because the square root would no longer be a function. So it's called the square root function because it's an actual function. Okay? Let's try a second problem. We're going to do 3. So, number 2. So this time I have y equals the square root of 4x. And again, these steps, step 1 says identify the domain. The domain is determined by the radicand, what's under the square root, because we can't take the square root of a negative. So whatever that radicand is, whatever is under the square root symbol, must be set greater than or equal to 0. And then we solve it for x, but if we have 4x greater than or equal to 0, what are you going to do to solve it for x? Divide both sides by,
4.
and if you divide 0 by 4, what do you get? 0. 0 divided by 4 is 0. So this is my domain. It's the same as last time, but that doesn't mean it's always going to be that. So if I start a table of values here, my x value in my table is going to start at that starting point. And since it's greater than or equal to 0, I know I want values that are bigger than. Now, this is where you got to do some thinking. Some people, it's very intuitive. I don't want to have to always rely on a calculator. Can you think of a positive number that if you multiply it by 4 creates a perfect square? What do you think, Elijah? 1. 1's a great number because 4 times 1 is 1. Anybody else, Tristan? 4. 4 times 4 is 16. Ava, do you have a different one?
No, but I was just saying, like, is it 4, since 4 is this perfect square, can't you do, like, 2 times the square root of x?
For the input, you mean, like put in for x? If you had 2, you said 2 times the square root of x?
Yeah, like,
We-
so, because 4 is a perfect square, so you can...
Right, but we would make x 1 so that that becomes 4 times 1 or the square root of 4. Does that make sense? Really, what you're actually doing is you're setting the radicand 4x equal to perfect squares. Now, we didn't come up with this one, but the first perfect square other than 0, which when we put in 0, we'll come back to that, but that's going to be 0, because 4 times 0 is 0. But the next perfect square, 1. Well, that would mean x is 1/4. I didn't put that in the table, but 1/4 would be an input value that could give you a perfect square. 4x equals the next perfect square of 4. We actually have that because somebody realized, oh, if you make x 1, you get 4 times 1 is 4, and that's a perfect square. Then 9 is not so user-friendly because that would mean x would have to be 9/4, which it's not like you couldn't put that in your table, but you don't need tons of values. You need at least 3 to get the shape. We know what the shape's going to look like. Half of a parabola opening horizontally. So let's put our values in. Yeah, Chase, question.
The x's on that column, you're putting that in for 0, not for the x.
I'm putting the x in here. So if I put in 0 for x, 4 times 0 is what?
0.
What's the square root of 0? Because y is what you get.
Right.
So what's the square root of
So
0?
okay, 0.
If I put in 1 for x, 4 times 1, Chase, is, what's the square root of 4? So this would be 2. If I put in 4, Chase, 4 times 4 is,
16.
what's the square root of 16?
4.
If I put in 1/4, what's 4 times 1/4? 1, what's the square root of 1? Now, I don't need all those values, but I have several. I can see what my range is as well before I even graph it. Because remember, the starting point for that half of the parabola should give you both domain and range, but you've got to be aware of what's happening with the values for x and y. And here, for the range, I'll just leave it blue, is y getting bigger or smaller when you look? Bigger. These are all bigger than 0. I might not have them in order, but that's okay. So this would be greater than or equal to 0 as well for the range. So let's graph it. So if I graph here, I'm going to graph 0, 0, 1, 2, this is going to be stretched, 4, 4, 1/4, 1 is kind of hard to get, but kind of like that. And I could keep going, as I said, but this is enough to get me the idea that my square root function is stretched because the 4 under the radicand is stretching it. It's not shifted off the origin here. Do we have questions? One more. That'll be our final example. Now, I will suggest to you that this could be written 2 ways. This could also be written as y equals the opposite of the square root of x plus 2 plus 3. I just reversed the order of the terms. And you'd have to be comfortable either way for identifying domain and range and graphing. So domain, remember, that's the first thing we want to do. That's determined by the radicand because it's the square root that puts the limitation on the domain. We can't take the square root of a negative, so I'm going to set x plus 2 greater than or equal to 0. And this time I have to solve it. What do I get when I solve that for x? Caitlin, what do you think?
X is greater than or equal to
X is greater than or equal to -2. I agree. So that means when I make my table of values, which I have a little room over here, I'm going to start at -2. And I want values that are larger than -2. So can you think of the next value you might put? Some of you get good at this and you're like, oh. And think, what's the next perfect square? If it helps, you could solve this to help you. Some of you don't need this, but the perfect square of 1, what would that make x have to be? What do you think, Ava? What value were you thinking?
I was thinking 2.
2 works. 2 is a good value. This, if I solve it, do you see if x is -1? That's a great value as well. Let me kind of separate this so it's easier to read. If we put -1, do you see how -1 plus 2 becomes 1, and that's a perfect square? And if x plus 2 would equal the next perfect square of 4, when you solve that, that becomes 2. So I like that. 3 is enough, but let's go one more. What's another value that we could use for x? 7? So let's think through. If I put -2 in, -2 plus 2 is 0. Square root of 0 is 0 plus 3 is 3. That's my starting point. That's going to help me know domain and range. We said domain. This is your domain. X has to be greater than or equal to -2. Let's see what happens with the range as we get our y values. So, you ready to help me with the next value or question, Chase?
Question.
Uh-huh.
What happens with the negative in front of the square root? Is that just like not doing anything?
Oh, good question. We didn't have to worry about it here because it's the opposite of 0. And 0 is its own opposite. So it didn't really affect anything. But this next value, it sure will. So let's try that. You can help me. -1 plus 2 is what? 1. The square root of 1 is 1, but that opposite really means it's -1. Plus 3 is what? 2. You see how that works? Let's try 2. Maria, 2 plus 2 is?
4.
The square root of 4 is? But then we take the opposite, so it's -2. Plus 3 is what? 1. Let's try 7. Josh, 7 plus 2 is? The square root of 9 is? The opposite means it's -3. Plus 3 is? What do you notice about your y values here? Tristan?
It's decreasing.
It's decreasing. It's getting smaller. So when I identify my range, what do you think I'm going to say for y? Jackson?
Y is greater than
If they're decreasing, do I want to say greater than? Yeah, I want to say less than or equal to 3. And that's because it's decreasing. And your graph, if you plot the points, it's going to become obvious why that is the case if you're graphing. So let's graph. I have -2, 3, that's right here. I have -1, 2 here. I have 2, 1 right here. I have 7, 2, 4, 6, 7, 0 right here. Do you see what's happening to your graph? Is that the top half or the bottom half of the horizontally opening parabola? Bottom. What do you think's doing that? What in the equation is making you get the bottom half, Jake?
negative.
Yeah, this minus right here is giving you the bottom half. You're taking the opposite of what you got, So as a result, you're getting the bottom half, which affects the range. That's why the y values are getting smaller. Does that make sense? Now, one final thing. What if Mrs. McCollum did this?
Come to it.
I will. Before I do that, let me do this. How does that change what I do in my graph? Shouldn't change a lot.
Makes it dotted line.
Dotted curve. So I could go like this. And where would I shade? Because remember, shading's involved. Below it. Less than is below, greater than's above. Now, you don't want to go beyond the starting point. A lot of times people will draw a vertical dotted line. That's the buffer, that's the barrier. And you want to be below the curve, but to the right of that line where the starting point is. Does that make sense? So you might have a few inequalities to graph where it's a solid or dotted curve, and you might have to shade above or below. But that should be the no-brainer because it's no different than what we did for any other type of curve, quadratic or linear, when we had inequalities. Questions? You got it? All right, let me pull up the homework. You're going to have a nice chunk of time to work. Let me see how